I'm Irene Zhang. Today I'm going to talk about Sapphire, which is a new distributed programming system designed to provide customizable and extensible deployment for mobile cloud applications. This is joint work with my co-authors at the University of Washington. So before I dive into the design of the system, I'm going to first talk about some of the application trends that motivate our work. Once upon a time, not so long ago, the applications that people interacted with every day were things that supported just one user, ran on a single platform, and spanned just one node. They're things like text editors and calendaring apps and games. Today, things look a little different. The applications that users interact with on a daily basis are some new things like Twitter, Pinterest, Facebook. There are also some of the old things, still text editors, calendaring apps, and games. But there's some big differences with today's applications. First, they support more than one user. Users share these applications. Next, users interact with these, which means that these applications must span a number of cloud servers. Next, users interact with these applications through their mobile devices, which means these applications now have to have mobile components. And last, these applications now have to coordinate across distributed components, often over links that are slow or unreliable. So all of this adds up to some significant new challenges for application programmers. They have to coordinate data and computation across distributed nodes. They have to meet application requirements and guarantees with limited performance and failures. And they have to do all of this across different programming environments and with varying hardware resources. So to your average programmer who's just trying to build a game where you throw birds at pigs with your friends, all of this sounds pretty daunting. But to the people in this room, these problems should sound really familiar because they're the kinds of things that designers of large distributed systems deal with every day. And this is great because it means that we have the solutions. Unfortunately, application programmers all seem to want different things. And we can't just ignore them, not just because they seem to be yelling pretty loudly, but because these solutions all involve performance trade-offs that only application programmers can make. And this has led to an interesting situation where application programmers implement the things that I have listed on this slide, which are complex distributed deployment tasks, directly in their application, or they use their application to stitch together a bunch of systems that provide these things. And this is really not a great situation. This code is hard to build, debug, maintain, and change. In this talk, I'm going to present Sapphire, which is a new distributed programming system designed to help application programmers with those complex distributed deployment tasks. Our goals with Sapphire are twofold. First, we want to separate the application from its deployment. But at the same time, we want to allow application programmers to choose the deployment that meets their application's needs and change that deployment if their application needs change without changing the application itself. We meet these goals with a unique and new system architecture that supports deployment managers. This is a new concept that we've introduced in Sapphire. Deployment managers run a single complex distributed deployment task for a piece of a distributed application. Here's an outline of the rest of my talk. I'm going to first talk about that unique architecture that I just mentioned. So Sapphire facilitates the separation between an application and its deployment with a unique three-layer architecture. I'm going to first give you an overview of this architecture, and then I'll talk about each layer in more detail. So at the top of this architecture, we have a distributed Sapphire application. It runs in a single uniform environment that spans mobile devices and cloud servers. At the bottom of this architecture, we have a distributed deployment kernel, or I'll call this the kernel for short, which provides that uniform environment as well as best effort distribution services. The most important part of the Sapphire architecture is this new middle layer, which is the deployment management layer. Inside this layer, complex distributed deployment tasks run in a number of deployment managers. And the two other layers of the Sapphire architecture are all specifically designed to support this layer. So first, let's take a look at what a Sapphire application looks like. Our programming model is based on distributed objects. Application programmers partition their application into a number of Sapphire objects, which can run anywhere, they can be called from anywhere in the application, and they can move transparent to the application. But most important of all, Sapphire objects provide a single unit of deployment for deployment managers to distribute and manage. Sapphire objects encapsulate other application objects. So, for example, if you have this game board object and it contains game pieces, the game board Sapphire object is going to encapsulate the game pieces for purposes of distribution. So if the game board moves, the game pieces move too. So at the bottom of our architecture, we have the Sapphire deployment kernel, or kernel for short. Like I mentioned before, the kernel provides best effort distribution services, and it provides these 4 Sapphire objects. It provides object tracking and mobility, and it provides best effort RPC to Sapphire objects from anywhere in the application. But the most important job of the kernel is to manage, distribute, and run deployment managers. So the kernel consists of 2 components. The first is the kernel server, which runs everywhere the application runs. And then there's also a centralized and fault-tolerant Sapphire object tracking service. So the middle layer, our deployment management layer, as I mentioned before, consists of a number of deployment managers. A deployment manager extends the functions and guarantees of that best effort kernel for a single Sapphire object. Deployment managers work by interposing on Sapphire object events in the kernel. And deployment managers meet our goal by making it easier for application programmers to choose a deployment that meets application needs and then change that deployment without touching the application itself. So application programmers choose the deployment for their application by choosing a deployment manager for each of their Sapphire objects. Different Sapphire objects can have different deployment managers. So now that you see the entire Sapphire architecture, you can see how deployment managers enable Sapphire's flexibility, because they're pluggable and they're extensible, and they're separate from both the kernel and the application. We provide a library of deployment kernels, deployment managers for application programmers to use. We have simple things like reliable RPC. We also have different kinds of caching. We have concurrency control primitives. We have durable checkpointing to disk. We have different kinds of replication for fault tolerance. We have more complicated scheduling and placement policies. And we have scalability and load balancing. So we expect most programmers to choose things from this library to easily create a unique deployment customized to the needs of their application. However, for those more advanced systems programmers in the crowd, the kernel also provides an API for extending the deployment managers that we have in this library, which are all built with this API, and for creating your own deployment managers. So now I've shown you how the Sapphire architecture makes it easy for programmers to choose and change the deployment of their application. So next, I'll talk about how we build deployment managers to make all of this possible. Deployment managers are distributed themselves.
because they implement complex distributed deployment tasks. Every deployment manager consists of 3 component types, which are entirely instantiated, distributed, and run by the kernel. The first type is the instance manager. The kernel always creates the instance manager with the Sapphire object. It invokes the instance manager to do server-side things, like handling RPC or synchronizing replicas. The proxy component is always created with remote references to the Sapphire object. And the kernel invokes the proxy for client-side tasks, like client-side caching and routing RPC. And finally, we have a coordinator component. The kernel creates one of these with the fault-tolerant Sapphire object tracking service. And it invokes the coordinator for centralized synchronization and coordination tasks, similar to the kinds of things that Zookeeper and Chubby would do. So now that I've shown you the different components of a deployment manager, let me show you how they're distributed. So from the application programmer's point of view, they have a Sapphire object, and it gets a deployment manager. That's all they see, right? But let's look inside this deployment manager to see what's really going on. So when the kernel instantiates this Sapphire object, it's also going to create the instance manager along with it. At this point, if the instance manager for this deployment manager needs replication, it can call the kernel to create a replica, which gives it a copy of the Sapphire object along with another instance manager, which can communicate through transparent RPC. So these instance managers then can later synchronize to coordinate their replicas. Next, the kernel is going to create a proxy for accessing this Sapphire object, or sorry, a stub, and it's going to create the proxy component along with it. And the proxy can call the instance manager in order to make RPC, and every reference to the Sapphire object gets its own proxy. And finally, the kernel creates the coordinator. So to make this a little bit more concrete for everyone, I'm going to give you a couple of examples pulled from our library of Sapphire deployment managers. So the first example I'm going to give you is how we do state machine replication for a Sapphire object. So again, from the programmer's point of view, all they've done is they've grabbed this deployment manager and attached it to their Sapphire object. But let's take a look at what's going on inside this Sapphire object. So the first thing the replication deployment manager does is create 3 replicas and then designate one of them to be the leader. Every time the application makes an RPC to this Sapphire object, the proxy intercepts that RPC and then forwards it to the leader, which then forwards that RPC to the replicas so that they can invoke it on their local Sapphire objects, and then call back to the leader, which will invoke the RPC locally as well, and then respond back to the proxy. So that's how simple state machine replication works for a Sapphire object in a deployment manager. Next, let's look at something that's more client-side oriented, like caching. So again, the application programmers just grab this deployment manager because they want caching for their application. But there's a lot more complexity, of course, going on under the covers. So for this deployment manager, we only need one copy of the Sapphire object, so we just create one to be the master replica on a cloud server somewhere. Next, every time something in the application makes a call to the Sapphire object, the proxy is going to intercept that call and check whether it has a locally cached copy of the Sapphire object. If it doesn't, it can call to the instance manager, which will create a copy for it and send it back. Now the proxy can invoke that RPC on a locally cached copy. However, it's going to have to keep that locally cached copy synchronized with the master replica. So in the last half minute, I've told you how 2 pretty complicated distributed deployment tasks work in deployment managers. Overall, when we were building our Sapphire library, we found deployment managers to be pretty easy to build despite how complicated the tasks they were implementing were. And this is because of the way the Sapphire architecture is designed. The deployment kernel provides all of the heavy lifting in terms of figuring out where to place components for the deployment manager and when the right time to call them is. At the same time, the application programmer is getting involved as well by partitioning their application into a Sapphire object, which creates an easy unit for the deployment manager to copy and move around. So just to conclude, I'm going to show you the implications of using different deployment managers on the performance of a Sapphire application with a few performance results. So our experimental setup had a couple of mobile devices and a cloud server. Our mobile devices were connected to the cloud server either through a local area Wi-Fi connection or a T-Mobile 4G connection. So the first thing I'm going to talk about is a multiplayer game that we built in Sapphire. So the point of this experiment is just to see how different deployment managers really have a big impact on how the application performs. So I'm going to give you the performance of the game in terms of latency for read and write operations to a game board Sapphire object, which provides most of the functionality for this application. So the first deployment manager we tried was a keep in cloud, which just keeps this game board object on a cloud server. The latencies are pretty even here for both players and for both operations because they all have to go to the cloud server. The next deployment manager we tried keeps the game board Sapphire object on player one's mobile device. So you can see here player one is really benefiting from that deployment manager, but player two is suffering a bit. And the last deployment manager we tried was a deployment manager that places a copy of the Sapphire object on each player's device and then keeps it synchronized after every turn. So in this case, you can see reads have gotten a lot cheaper, but writes are more expensive. So this experiment shows that performance is really different with these different deployment managers. And while the application programmer still has the extremely difficult job of choosing which of these to use, once they've made that choice, it's easy to implement. And if they'd like to change it, it's also easy to change later. For my final set of results, I'm going to show you a physics engine that we deployed in Sapphire. So this was not a distributed application. This is just a physics engine that does computation for objects in a game like Angry Birds. We took the most computationally intensive part of the physics engine and stuck it in a Sapphire object, and then applied this code-offloading deployment manager to it. So I'm going to give you the latency to do the computation in milliseconds again. So you can see the baseline for running this computation on the phone and the tablet is pretty expensive, but also you can see it's pretty different for the two mobile devices. So most notable is that for the phone, we couldn't even get real-time rendering because it was so expensive to run this physics engine. But after sticking this application into a Sapphire object and attaching the code-offloading deployment manager, we were able to offload the computation to a cloud server over both Wi-Fi and 4G. And so you can see that we significantly reduced the latency for this computation just by partitioning out the expensive code and putting it into a Sapphire object. You can also see that the environment here is really heterogeneous, so application programmers are really facing a difficult task. So again, I'll just mention that once the application has made the decision that they want to code offload this piece of the physics engine, it's very easy to implement that decision in Sapphire and then change it later if they'd like. So in summary, I've shown you that modern application programmers are faced with the difficult task of tackling distributed deployment in their application. We've designed Sapphire, which is a new distributed programming system, to help with the deployment of these mobile cloud applications. Sapphire has a new architecture that supports deployment managers, which enables these application programmers to easily choose, change, and build deployment without touching the application itself. Thank you, and I'll take some questions.
Hello, my name is Kautar El-Maghrawi from IBM Research. So my question is about how flexible, your system is in terms of specifying, for the application programmers, what types of deployment. Like sometimes applications have conflicting requirements, and also sometimes the application programmers really do not know what type of deployments will make it easy for them, to get the type of quality of service, they need. So do you have like some types of templates, that allow application programmers to know, like it's good for you to use these deployments versus others?
So that's a great question. Again, I mean, you're just highlighting how difficult this job is for application programmers who are not especially skilled at distributed systems. So I'll give you an example of our code-offloading deployment manager. So our code-offloading deployment manager is actually adaptive. It can measure the latency of your RPCs and figure out where the best place to run them is. But what we're asking the programmer to do is tell us that they think this piece of code is computationally intensive, partition it out to make sure that it's just doing computation, so we're not going to do a lot of expensive synchronization. And then from there, we can take it, right? We can do the adaptive code offloading by measuring the cost. And so in contrast to today, what you would be stuck doing would be either implementing, the code twice, once for the mobile side and once for the cloud side, or you can use one of these code offloading systems, which has to do pretty complicated program analysis, code analysis, just to figure out what code they can partition out and what code is it even makes sense to partition out. And so we get a little bit of information from the application programmer and are able to do something pretty powerful with it. But we definitely, this is not a magic bullet.
Okay, thank you.
Thanks.
I'm Howie Huang from George Washington University. So very interesting work, but since we are talking about mobile systems, I just wonder if you have plans to deal with issues like dependabilities, security, as well as like energy consumption, those type of issues.
Yeah, that's a great question. So basically you're highlighting the fact that these mobile systems have a lot of other issues they have to deal with too. It's not just about deployment, there's energy, there's security. So I'll tackle the energy question first. We haven't looked really at energy. I think it would be great if people could build deployment managers, that take into account energy. And that would require the kernel to have some energy monitoring built into it, right, to give you the right kind of information. So right now, the kernel can give you latency information, tell you when something is expensive, but it can't tell you how much energy it's using. So the privacy and security question is interesting too, because we're actually working on something now that uses a platform very similar to this one, to do basically to give users better guarantees about the privacy of their data. We can talk offline about that if you're interested.
Hi, Phil Bernstein, Microsoft Research. You're talking about cloud applications, but your experiments were for a single server. And in addition, your deployment manager is centralized, which looks like an obvious bottleneck if you start scaling out to large numbers of machines. Can you just tell us what expectations you have for scale out here and whether you have other experimental evidence to tell us what the limits might be?
So there are experiments in the paper. Did everyone catch that? Should I repeat the question? Okay. So there are experiments in the paper for scalability. We definitely tested it with more servers because we have some other deployment managers that handle, if you have a single overloaded Sapphire object. In terms of, so deployment managers themselves are definitely not centralized. What we do have is the centralized object tracking service, which tracks Sapphire objects. But it's used very rarely. So again, we're imagining something like Chubby. In fact, we could use Zookeeper. That would be perfectly fine because it's only responsible for tracking when Sapphire objects move and when things fail, which I think people have been able to do. Was there another part to the question?
Well, if I have a multiplayer game where I've got 100,000 games active at any given time and people are coming and going, are you going to be able to handle the creation and destruction rate and scale out in that? I mean, you're
Oh,
talking
okay,
about, you
right.
said, you said they don't move very, that they don't talk
Right.
to this
Right,
location
right.
manager very often.
So that's a great question. It would definitely become a problem if it was happening, a lot. I think the other thing we imagined was that, Sapphire objects are sort of like virtual nodes or things that are shared. We imagine that most of them get created on cloud servers because you need to be able to access them. And so if they're located on a mobile device, you're not going to be able to, access that Sapphire object as soon as the person leaves Wi-Fi range or, doesn't have a connection. And so most of the games, the games that we built, the Sapphire objects are hosted on the cloud just like you would for a game today.
Thank you.
Thanks.
Thank our speakers for this.